Okay, in this video we're going to talk about synthetic division. You may in earlier math courses have learned how to do polynomial long division, but in this class we're going to focus our efforts on synthetic division, which is a much easier way to do it. In this problem, it says use synthetic division to divide. I'm dividing the polynomial 4x squared minus 5x minus 6 by the binomial x minus 2. So your power is less here, so it's going to be an easy division. Now to use synthetic division, what you would actually do is you have to think what number would make this divisor 0. So what number could I substitute in for x that would make this divisor 0? So positive 2 would be what I'm going to use for my synthetic division divisor. Whatever would make this 0 is what you're going to use. So I'm going to use positive 2. Okay, so that's going to block that off. Now the coefficients of what you're dividing into are 4, negative 5, and negative 6. Notice they are in descending order, and all of my terms are in there. So I have the squared term, I have the x to the first power term, then I have the constant term. So this is in perfect form for division. So I will write those down: 4, negative 5, and negative 6. So to do synthetic division, this is always the steps that you're going to follow. On the first term, you just bring it down like it is. So we're going to bring down the 4. Now, multiply 4 times the divisor. 4 times 2 is 8. So I'm going to bring that to this column. Now, add this column together. Negative 5 plus 8. Add that together, and I get 3. Okay? Next step, 3 times 2, which is 6. Then we're going to put that in this column and then add. So I have 0 as my blocked off. Whatever you get on the last vertical column addition, that's the remainder of your division. So this one has no remainder at all. Since we divided x squared by x to the first, this leading term would be an x to the first power. So the quotient here will be 4 x to the first plus 3. That's the quotient after you divide. Let's try another one. 3x to the third plus 8x squared minus 8 divided by x plus 2. So to use synthetic division correctly, our divisor in this case would have to be negative 2, since that's what would make the denominator 0. So negative 2 is going to be my divisor. My coefficients in descending order are 3, 8, 0, and negative 8. And you might wonder, where did the 0 come from? The 0 is there because you're missing a term where you have x to the first power. You have your third power, second power. I need my x to the first, and then my constant. So you have to put in any zeros for missing terms. So we're going to just go through the steps now. Bring down the first term as is. 3 times negative 2 would be negative 6. Add that column. 8 minus 6 would give me 2. 2 times negative 2 is negative 4. Add that column, I get negative 4. Negative 4 times negative 2 is 8. Add that column, I get 0. Again, I have no remainder. So let's think about this for a second. X to the third divided by x to the first. If you subtract the powers, my leading power on my quotient should be x to the second. So the quotient here will be 3x squared plus 2x to the first minus 4. All right. Let's try one more. In this one, we have x to the fifth power divided by x plus 1. So my divisor would be negative 1. You have 1x to the fifth. You have no x to the fourths, no x to the thirds, no x squareds, no x to the first power, but then you have a constant of negative 1. I have to put all those zeros in there to hold the places of missing terms. We're going to bring down the first term as is. 1 times negative 1 is negative 1. Add that column, you get negative 1. Negative 1 times negative 1 is 1. Add that column. I get a 1. 1 times negative 1. Add the column. Negative 1 times negative 1. 1. Add the column. 1 times negative 1 is negative 1. So add that column, I get negative 2. Block that off as my remainder. So if you think about this, x to the 5th divided by x to the 1st. My highest power should be x to the 4th. 5 minus 1, so x to the 4th. 1x to the 4th minus an x cubed plus an x squared minus x plus 1. And then, since you have a remainder, what we do is we say, since it's minus 2 over the divisor, x plus 1. So anytime you have a remainder on your problem, you're